Good morning to everyone. So today topic is rise in sea level. So what is sea level rise? So sea level rise is one of the most significant effects of climate change, right? So sea level rise, that is called SLR. SLR, sea level rise. So it is one of the most worrying impact of global warming, right? So sea level is the base level for measuring elevation and depth on Earth, right? So hence sea level rise is the climate change phenomena through which the ocean water volume increases, mostly as a consequence of ice sheets and glaciers melting and also water thermal expansion, right? So as a consequence of sea level rise, coastal life around the world, it is threatened and adaptation policies need to be developed to avoid further and faster catastrophic impacts, right? So now you see here, so this is the definition of the sea level rise. So a sea level rise is an increase, see, increase in global mean sea level as a result of an increase in the volume of water in the world's oceans, right? So climate change, it has a significant impact on the sea level changes as well, right? So it means all these attributes are going to be impacted in one way or the other way, or directly or indirectly, right? So if you see this figure, the climate change has various attributes or various impacts on various attributes, right? So what is the precipitation? Precipitation runoff and CO2 levels and sea surface temperature, that is called ST, right? And then you have a sea level rise here. This is the important thing here. So where we are concerned right now, and wind wave and storm intensity, right? So if you observe, all these factors are importantly related to climate change, right? So if you observe one part that is sea level rise, how does it influence or impact the various attributes related to the coastal areas, right? So now you understand. So first important is where it is linked with sediments, right? And nutrients. So which is related to directly coastal flooding, right? Then we have wetland production. So that is directly impacted by ocean acidification, right? Then we have algal blooms. So that is also directly related to coral bleaching, right? So, and we have coastal erosion. So that leads to inundation, right? So then we have beach rotation, which is linked to benthic damage, right? And then lastly, we have infrastructure damage. So this is related to the, what is that? Storm surge and cyclones, right? So that we observe here, right? So when we say the sea level changes, it means all these attributes are going to be impacted, right? Going to be impacted in the one way or other way, directly or indirectly, right? So this is important. So if you observe this coastal flooding here, right? So coastal flooding, ocean acidification, and coral bleaching, and also inundation, and benthic damage, and storm surge. So all these factors are directly or indirectly related to the sea level changes. And why we are worried about this? Because it has been observed that due to extreme climate change, due to extreme global warming, the levels of the sea is rising. And it's going to further rise ahead in the coming terms, right? So that is one important point where we are also concerned about it, right? So now let's elaborate further more details. You see here. So now when we say the sea level rise is basically what it is an increase, right? Increase the level of the world's ocean. So that is due to the impacts or effects of climate change, especially which affect global warming, right? Global warming, which is induced by three primary factors. First one is thermal expansion, and second one is melting glaciers, and third one is loss of Greenland, and Antarctica's ice sheet. So third one is not here. So that is another topic. Okay. So I will tell about this one later. Okay. So first one is thermal expansion. So this is the very, very important. So thermal expansion. So what is this thermal expansion? So when water heats up, it expands, right? About half of the sea level rise, the past 5 years is attributable to warmer oceans, simply occupying more space, right? So when water heats up, what happens to the water? It expands. What is that? It expands. So when it expands, what will happen? About half of the sea level rise over the past 5 years, not 5 years, this is 25 years. So past 25 years is going to be attributed to what? Warmer oceans, right? So it means expanding and it is occupying more space, right? So the thermal expansion part that is giving rise to the sea level, right? So the thermal expansion is the increase of the substance when it's heated, right? So we all to know heat expands and cold contracts, right? So the reason for the increase in ocean temperatures is due to the increase in atmospheric greenhouse gases. So which began with the Industrial Revolution. So the okay. So the UV and infrared and visible radiation come into the air, and then infrared radiation now bounces off of the air, and instead of bouncing off and leaving Earth's atmosphere, right? So it gets trapped by the greenhouse gases. So that just happened to absorb this exact type of radiation. And how convenient this leads to an increase in atmospheric temperature. And oceans absorb how much? 90% of this heat, right? So, sorry, it's not easy. Now, you see here, you can see in this graph shows an increase in global average temperatures, right? Global average temperature since the end of the Industrial Revolution, right? So due to greenhouse gases, and this has a direct effect on ocean temperatures, right? So since 1880s, you see here 1880, global sea level has risen 8 to 9 inches. How much? 8 to 9 inches. You see, 9 inches, with 1/3 of that occurring in the last 2.5 decades, right? So as you can see in the graph and from the statistics, so in the bottom left, the rise is only accelerating, right? So in the 20th century, averaged an increase of how much? 0.06 inches per year. And then the year of 1990, it was 0.1 inches. In 2010, how much? It was 0.12 inches. And today, it is a whooping of 0.14 inches per year, right? So this is the thermal expansion and melting glaciers. So it is very commonly understood by all of us, right? So that is, if glaciers melt, what happens? Due to rising temperatures, so what will happen? There will be a rise in the sea level automatically. Why? Because what happens? Due to the large areas of ice or snow, which is melting, right? So it will lead to the diminishing of the glaciers, and at the same time, what will happen? It will change the seasonality in seasonal patterns. So that is a snowfall due to later winters, and earlier springs. So that is related to the climate change, right? So, and also what happens, it leads to an imbalance between the runoff and ocean evaporation. So now remember, runoff is related to the surface water. So that is brought from the river to the ocean. And we say runoff and ocean evaporation, if this balance is reduced or if this balance is actually disturbed. So it means that if there is more runoff and if there is less evaporation, right? So what will happen if there is an imbalance, that will lead to sea level rise. So that is one important thing here, right? So apart from the salinity temperature changes as well, that we already know, right? So these are the two major factors, that is thermal expansion and melting of ice. So that is equal to rising sea level. So which are of prime importance in terms of global warming and sea level rise, right? You see some of the pictures. So these are some pictures in melting glaciers. So this picture from the 1941, you see. So totally it is freezing, right? So in the year of 2008, so same area and same location, it is melting, right? So you see here, Greenland and Antarctica sheets. So the sea level is going up because of the 20th century is experiencing a period of strong global warming, and that leads to the expansion of the ocean waters, warmer water. It simply takes up more space, and also it leads to melting of continental ice, the mountain glaciers, the ice sheets in Greenland and Antarctica. So they are all losing the ice, and that water ends up in the ocean, pushing up the sea levels. We know that sea level has risen about how much? 15 to 20 centimeters since the late 19th century. You see. So the Greenland and Antarctica ice sheets are one of the biggest concern of for longer term sea level rise. So with an area of how much? 2.16 million square kilometers. So the total 80% of Greenland is covered by this ice cap, right? So with a population of more than how much? 57,000 people, right? So Greenland's ice melted more last year than any year before. It has been found that in 2019, right? So, yeah. So Greenland lost about 532. How much? 532 billion tons of ice with 223 billion tons of ice in July 2019, right? So in case the entire Greenland melt, so what happens in the world? So many or so millions of people will die, right? So the entire Greenland ice sheet melts, sea level would rise by 6 meters, that is worldwide. So millions of people will death or die, right? So as with mountain glaciers, increased heat is causing the massive ice sheets that cover Greenland and Antarctica to melt more quickly and also more quickly into the sea. So remember, if the areas of these particular continental ice sheets those are exposed to intense heating, what will happen? It will add more volume of water to the sea, right? So thereby changing sea level, right? So these are the three major primary factors which are of a prime importance in terms of global warming and sea level rise. So now the IPCC released some special report on ocean and cryosphere. So the cryosphere, it contains the frozen parts of the planet, right? So it includes, what is that? Snow and ice on land. So ice caps, glaciers, and also permafrost and sea ice, right? So the oceans and cryosphere in changing climate, which underline these changes taking place in oceans, glaciers, and ice deposits on land and sea. So that is where the concern came from this particular report by the IPCC. So what does it say? The report experts that ocean to rise between how much 10 to 30 inches by which time 2100. So almost in next 8 years. So that is going to rise by 10 to 30 inches because the temperatures warming up to 1.5 degrees centigrade furthermore, right? So if there is 1.5 degrees centigrade rise in temperature, it will lead to about how much? 10 to 30 inches rise in the oceanic area across the world, right? So that is importantly in terms of the sea level rise or sea level changes that we observe around the world oceans according to this IPCC report. Okay. You see some of the pictures here. So you see Greenland ice sheet under 6 degrees centigrade global warming, right? So this is 1 meter, up to 1 meter, and this is 3.2. You see the difference between here, this ice sheet, and so 3.2. And this is also 3.2 meters and 5.1. You see here? 5.1. So you see from here to here difference. This is 1 meter and this is 5 meters. And also this is 4.6 meter and 6.2 meters. And lastly, 7 meters. So total entire Greenland ice sheets maximum, it is melting, right? So you see sea level rise. So that is historical changes, right? So in our past changes, what we have seen the changes in sea level from IPCC analysis. right? So the IPCC analysis of 1998 in 2001 and 2004, what we observed since the last last glacial maximum, right? So remember the 20,000 years, 20,000 years, that is what we say last glacier maximum happens here, right? So the mean sea level, MSL means mean sea level has risen by 120 meters. So that is a great amount of rise. So if you see in last 20 years, right? So then between 15,000 and 6,000 years ago, the mean sea level rose up to average rate of 10 millimeters per year. So that is very important. And following last glacier period, local vertical land movements are still occurring today as a result of large transfers of mass from the ice sheets to the oceans. So this is also changing the isostasy through U-static. What is that? U-static. So I already told this isostasy and U-static in your previous class, right? So an adjustment sea level rise is considered under U-stacy, right? And in last 6,000 years, what has happened there? So the global mean sea level variations on time scales of a few hundred years and longer are likely to have been less than 0.3 to 0.5 meters. So apart from that, so this IPCC report also says what? So that during 20th century tide gauge data, it means tidal data shows what? That range between 1 to 2 millimeter per year more than 19th century. 19th century. So in last 100 years rate has increased, right? So this is what is we are learning, right? So and also there is a decadal variability. So now in 10 years, there is a variability that has been observed, but no evidence of widespread increase in extremes other than that associated with a change in the mean value, right? Mean value. So I think so. This slide is up to here cutting. Okay. So the mean value or that mean sea level value, it has been observed in different part of the world, right? So where we concern in this has been the historical changes from last 20,000 years, right? So that is last glacier maximum till present. So that is we are talking about decadal is that variability, right? So and there is a prediction that by 2100 it will be rise in sea level furthermore about how much? 30 inches. How much? 30 inches. So this is very important. So that we are observing, right? So that is important in terms of this historic changes, right? So now you see the concern is population is right. You see. So human population, right? What is that? Human population. So that is where we are more concerned about that, right? So if there is a rise in sea level, so what is going to happen? So remember, there is a vulnerable population growth that regions in various areas of the world, right? So the vulnerable population regions are populated regions, and their predictions which have been mentioned here, right? So if you can observe this, so if you see this particular map, in this map, the particularly coastal parts of India, which is heavily populated here, you see, right? So this is the India, right? So then again, the Southeast Asia, is that Southeast Asia, that is also heavily populated in some parts in Africa, right? So this is Southeast area, and this is the Indian coastal areas. Sorry. And also this is the Africa, right? And some parts in here, South Americas, and also some parts in North America as well, right? So apart from the European nations as well. So what we see, considerably populations are going to be affected a great deal, right? So that is one important. So what we observe here, large coastal cities, right? Large coastal cities, that is populations having greater population. Then how much? 8 million. 8 million over 50% of United States population live in coastal areas. So that is greater than how much? 110 millions. 110 billion. So that is a huge amount if you observe just for United itself, right? United States itself. So and then if you consider the whole world, it is going to be a huge number that is going to be potentially impacted. Potentially impacted by the which one? Sea level rises, right? So that's why we are worried, right? So if you observe highly populated in delta regions of the world, so remember vulnerable. So vulnerable to what it is mean sea level rise, right? Mean sea level rise. So if delta regions of the world, those are to be considered, the mean sea level rise is going to impact. So if you see what are going to be the impact in coastal regions, more susceptible to storm surges, floodings, and beach or coastal erosions. So this is going to be impacted, and disruption of activities, danger to life, and infrastructure damage. So these are the potentially threats to us, right? And then 1 meter rise in mean sea level would enable 15 years storm flood areas, right? So that today are only flooded by 100 years storms. So you see the amount of area that is being flooded in how much? 100 years presently, right? So it will be flooded just in 15 years, just by 1 meter sea level rise, right? So that is a big concern across the world, right? So now here, so these areas, those are such, is the South Asia and Southeast Asia, which is going to be the most vulnerable group, right? So apart from some parts in Europe and some parts in Americas as well. So that is going to be one of the most important areas, right? Now, effects of sea level rise. So what are the effects? So now, first one is urban flooding. So it has become one of the most major features, especially on those areas which are part of the coastal cities, right? So you see some pictures of these coastal cities here. So this is India. So this is out of India. So because of storm surges and also, so because of the drainage or waste or sewage systems, so that are now contaminated. So we see lots of urban flooding happening as well in futures. Is it correct or not? Is it correct? Right. So, and flood damages would increased up to how much? 58% for 30 centimeters rise even in sea level. And we are expecting by 2100. How much? About 30 inches of rise, 30 centimeters or 30 inches of rise. So just imagine how much would be the flood damages by 2100 years, right? So at this particular rate, so that is the concern related to vulnerable populated regions across the world, right? So then what are the problems related to, you see some of the pictures here in Indian coastal regions. So this is 1 meter, 1 meter sea level rise, you see here, then 50 meters. So 50 meters, you observe this spot and this spot here, it is going inside. It means water is going up to here, right? The next 100 meters. So you see the variation of 1 meter, 50 meters, and 100 meters, right? So you see. So mostly these parts are completely full of water to here, and then this part also. And this is, I think this is the total AP and Telangana, and this part also. You see here. Right? So this is the Mumbai area in India. So you see particular Mumbai only. So this is 5 meters sea level rise. So it's showing like this, and 50 meters. So you see, and 65 meters up to here, water is going to, up to here, right? So now then, what are the problems related to sea level rise? If you observe carefully here, the first one is the salt water intrusion, right? So the salt water inclusion, so salt water will penetrate further inland and upstream in the estuaries, right? So salt water intrusion is going to be the major threat, right? So what will happen? The estuarine area, remember the estuarine area means that is where you have river water mixing with the ocean water. You see here, so this is the river and this is the ocean water. So this part is called estuarine area, right? So then highly salinity impedes both surface water and human as well, and not just surface water. We are dependent upon groundwater supplies, right? So this saline water, if it comes to the land area, it is going to also impact our groundwater, right? Groundwater resources. So that is going to be a key concern as well, right? So, and apart from that, the salt water, right? The salt water intrusion, it would also harm ecosystems. In what ways? So that is, first one is aquatic plants and animals. So that is salt marshes and mangroves are going to be impacted. And higher salinity has been found to decrease the seed germination. So there is going to be a lots of problem on agriculture in horticulture. So then flooded agricultural land takes a long time to actually recover, right? Recover from that salinity water, right? So if there is a salinity increase in the land, you cannot do anything. It is going to be rendered, degraded, right? Rendered and degraded land. So that is the biggest problem that we are going to face if there is going to be a significant rise in sea level in future. Remember this, right? So now we are going to problems not directly climate change. You see, what are the not directly problems in climate change? So the problems not directly climate change related, but they are problems, remember, right? They are problems. So what are those? First one is the tides. And second one is storm surges. So the tides, that is periodic changes due to changing orbital motions of the Earth and Moon. So that is going to be also impacted, right? So tides are periodical rise. The word again is periodical. It means so these are the tides figure. Right? It means at a given interval or at particular time period, right? So that is important. And what is exactly the fall of sea levels or the rise of sea levels, right? So the rise and fall of sea levels, that is what we understand as tides, these tides. right? So, and we already know there is a gravity influenced by sun and moon on the earth, right? So that is where it is created. Now remember, there are vertical movement of waters, and we said that is wave, right? So we said it was horizontal movement, but tides are what? These are vertical movement, unlike waves, right? That is waves. So waves are the horizontal movement. So here is important point to note that water movement which are caused by meteorological effects like said above are called surges, right? What is that? Surges. So now remember, when there is a tidal action which is vertical, not horizontal. So these are also termed as surges. Right? So because surge is the upward movement, right? So it is not like a regular tide because of certain meteorological factors as well, the movement of water surges. So during cyclones, we tend to use this word surge as well. So the surge along with the tide, when it combines, it is a greater force. That is what we see, right? So the moon's gravitational pull to a great extent is the major cause of the occurrence of tides. And many people think that is only moon is responsible. So remember, this is a myth and don't confuse yourself that only moon is responsible. Remember, sun is also responsible, not just the moon, right? So, but the moon's gravitational attraction is more effective. So that is important point. So because the sun is very far away, right? So the concept of gravity, the distance, right? So the distance plays a pivotal role because moon is close to the earth. It has more influence on the earth. And that's why it attracts the water, and that's why these water surge up, that is in the form of tides. Right? So the sun's gravitational pull, that is also the centrifugal force due to the rotation of the earth, and that is where it attracts and also lead to the tidal formation. But comparing the sun and moon pulls, moon is the greater force, that is important point, right? So the highest tides in the world occur in the what is that? Bay of Fundy, F-U-N-D-A, Fundy. So this is in Canada, right? Now storm surges like atmospheric effects are also going to be there. So in words, barometer and tropical storm or hurricane surges. So these are going to be a part of these impacts which are not directly related to the climate, but there is a impact. So then wind stress driven surge is also going to be impact, right? So now you see here, then these are the not directly problems, and these are directly problems. So directly climate related impacts. So now those are isostatic, eustatic, and steric. Right? So what is isostatic? Isostatic means, so what is that isostatic level changes, right? So which we already discussed in details in previous. So in isostatic morphology, that is vertical movement of the land. What is that? Vertical movement of the land. So in eustatic means that is changes of total seawater mass. Total seawater mass. So that is going to impact is as well, right? You see here any uniformly global change of sea level that may reflect a change in the quality of water in the ocean or a change in the shape and capacity of the ocean basins that results in change in sea level. This is the eustatic or eustats, and steric. Steric means that is the thermal expansion of water volume, right? So these changes, isostatic, eustatic, and steric changes are directly related to the climatic changes that we observed in the oceans. So this is going to be the greatest impacts, right? Remember this. These are the greatest impact, right? So now, mechanism. What are the mechanism of the change in sea level rise? So now, you see how it changes. How it changes. So the fluctuations of the sea level rise involve three basic mechanisms. These three basic mechanisms. So those are, first one is changes in ocean water volume and changes in ocean basin volume and changes in the geode. So these three basic mechanisms are important in this thing, right? So first one is changes in ocean water. So that is, it means the shape of the earth. Sorry, changes in the geode. Geode means shape of the earth, right? So because of mass changes, there is a potential that shape of the earth is also going to be impacted, and of isostatic and eustatic changes, and also changes of ocean water volumes, and also changes in ocean basin volume, right? So these three basic mechanisms are here. And so such changes occur due to these factors, right? So now you see here the changes in the volume of mid-oceanic ridges and accumulation of sediments on the ocean floors and impacts of orogenesis, that is Tibetan plateau, and drying out of small ocean basins and geoidal effects hypothesis and short-term changes in global sea level. So these are the changes occur due to these factors, right? So now first one is changes in the volume of mid-oceanic ridges. So this is going to impact, it has been observed since late Cretaceous period. So that there has been a steady increase in volume of mid-oceanic ridges, right? And the next, accumulation of sediments on the ocean floor. So this is also going to be impacted. And third one is impact of orogenesis. So impact of orogenesis, that is mountain genesis. For example, if it is assumed that in the Tibetan plateau, it is made up of crystal layers of twice the average thickness, and it is going to produce a fall of global sea level by 26 meters due to increased volume of ocean basin. So this is also going to be balanced check and balance option for orogenesis. Remember, this is going to be a global change in isostatic levels, right? So then next, drying out of small ocean basins. So what is drying out of small ocean basins? The small ocean basins are going to be dried out. What is that? Dried out. So, for example, an analogous, you see here, analogous evidence of this desiccation and sea level rise is found in case of the southern part of the Atlantic oceans. So if you observe in a nascent means in the earliest stage of development, right? So in a nascent stage, in the early stage, so what happens in Cretaceous period when the isolated ocean basin dried out, this led to a rise in sea level because of water of southern part of Atlantic Ocean return to the water body of the surrounding areas, right? So if there is going to be a local ocean basin changes, so that can be part of the mechanism or the factors for these changes, right? So we have all these major planetary processes related to geomorphology. So that are going to impact the entire scenario of how the masses and volume is distributed across the world that is related to water. So that is going to be major issue in future, right? The next, geoidal effects hypothesis. So this hypothesis was a model developed in the year of 1970s by geophysicists and many geomorphologists who predicted that 6 ocean basin zones, right? So which witnessed Holocene sea level change. Remember the last glacier maximum coming from Holocene sea level change, right? Due to both isostatic as well geoidal changes. So however, the sea level changes due to geoidal impacts is still not proved, but there is a kind of hypothesis. So that tries to say that, you know, if there is this change is going to impact due to the isostatic changes. So the isostatic changes and the ocean basins are going to be impacted, and the geoidal that is our earth shape that is going to get impacted also, right? The next is short-term changes in global sea level. So that is going to happen to 5 to 6 centimeters in sea level is absorbed in 1 year, right? So, and if it is going for a further fluctuations of sea level reach, how much? 20 to 30 centimeters or more. So in all areas of the world, that is going to happen. So then it happens due to short-term factors. So what are the short-term factors? Those are density changes and atmospheric pressure and velocity of ocean currents and ice formation and falling sea level, and also lastly, filling up of water along windward coast, right? So So now you see, in this diagram, the low pressure, you see here low pressure, then you have sea level, right? Sea level here. So this upward movement of air current, and this is the local changes that is happening here. Then sea level, the sea level rise and sea level fall, sea level fall. So this is going to happen in the direction of ocean currents as we observe here. Ocean currents, these ocean currents, right? So these are the local changes of short-term factors that related to the sea level changes at particular places. So this is also give impacts to the long-term changes also, right? So this is the sea level rise impacts and effects, right? So this is important things in your examination, okay? So just wait, I will upload another PPT. So now, global warming, right? So which is the one of the major problem of 20th century, right? Sorry, 21st century. Now, so what is greenhouse effect? First of all, you see, the sunlight causes the earth. Okay, so the sunlight causes the earth surface. This earth surface to heat up. So now this earth surface that radiates the thermal infrared radiation, right? So now there are gases in the atmosphere like, what is that? Carbon dioxide, NO2, and water vapor. So they together injure, right? So that this infrared radiation is not allowed to leave the atmosphere. Why? Because of a number of human activities. As you would know, the amount of this carbon dioxide in the atmosphere is continuously increasing day by day. And because of that, more and more heat gets trapped in the into the atmosphere. And the atmospheric temperatures goes up, and it has been going up lately. So greenhouse effect is causing the earth, that is to slowly get warmer, and this is precisely the phenomena which is commonly known as the global warming, right? So greenhouse gas, it means any gas that has the property of absorbing infrared radiation that is emitted from the Earth's surface and radiating it back to Earth's surface, thus contributing to the greenhouse effect. So the global warming is the long-term warming of the planet's overall temperature, right? So this warming trend has been going on for a long time. So it has significantly increased in the last 100 years. Okay. So since 1992, each year has been one of the warmest years on the record. From 1992. So you know, since record keeping began in 1895. So the hottest year on record worldwide is 2016. 2016, according to NOAA and NASA data report, right? So the year Earth surface temperatures was 1.78 degrees Fahrenheit and warmer than the average across the entire 20th century only. Before 2016 and 2015, it was the warmest year on record globally, right? So the Earth's temperature is still increased day by day, right? So because of what is the reason? That is mainly humans and natural activities, right? So the greenhouse effect is the main reason for global warming, right? So it is defined as the increase in Earth's surface temperature, and it is caused by the trapping of atmospheric heat. So this process causes Earth warmer than normal by direct sunlight, right? So the ultraviolet rays and infrared and visible radiations are reached the Earth's surface from the sun. When the sun's energy reaches the Earth's atmosphere, some of it is reflected back to space and some is absorbed and re-radiated by greenhouse gases. So the greenhouse effect is caused due to the gases which absorb and reflect radiant energy, right? So you see, this is the greenhouse or glass house. It's called glass greenhouse. So you see this picture, it is a greenhouse building, right? So it is made up of with glass walls, these glass, totally glass roof. So the totally it is a glass structure. And you can see small plants as well in there. So, but there is a specific reason why that structure exists. So, you know, the clear glass, this clear glass allows sunlight to shine into the greenhouse, right? So, but does not allow this heat to escape, right? So, let's understand what exactly is happening. So the solar radiation can easily pass through glass. So now what happened then is the ground inside the glass house is heated up. When this ground is heated, it radiates thermal infrared radiation. So now the glass material does not allow this radiation to pass through. So the heat is trapped inside the glass house, and because of that, right? So the temperature inside the glass house rises. So these are called greenhouse or glass houses, right? So this is how a greenhouse keeps plants warm even at night and in the winter time, right? So now our atmosphere contains a number of different types of gases, right? So it mostly made up of nitrogen and oxygen. So nitrogen is about 78% and oxygen is about 21%. So the greenhouse, but it also contains a number of gases. It is known as greenhouse gases, right? So the gases are responsible for the greenhouse effect is called greenhouse gases, right? So I can say in simple sentence, that is, what is that? Heat trapping gases. Heat trapping gases. So all the heat trapping gases are called as greenhouse gases. So basically, greenhouse gases are a group of compounds. So there are lots of gases that are able to trap heat in the atmosphere. So you see the greenhouse gases when present in the moderate quantities, and it helps retain the heat received from sunlight. So that's helping in maintaining moderated temperature necessary for survival of life on Earth. So these greenhouse gases are good, but when they are in the right quantity, so they form a layer around the Earth which acts like sort of a light blanket. When the sun rays are reflected into the Earth, some of these rays are absorbed by the Earth, right? So now, you see the main reason for global warming is human activity. So some of the human activities like such as burning of fossil fuels and industrialization and deforestation and also environmental pollution, these are causes increase in the greenhouse gases. So these are increase in greenhouse gases results in more heat being trapped on Earth's surface, right? So thus increasing the average temperature is causing global warming. So this is the definition of total global warming, right? So in next class, I will tell what are the greenhouse gases. I will explain one by one. Okay. So in afternoon class, I will explain about this greenhouse gases one by one. Okay. So now class, I can stop now.